All right, let's dive in. Today, we're talking about fractions. And I know, it sounds like something straight out of grade school, but trust me, there's a really cool, powerful logic hiding inside them. We're about to uncover the one secret rule that makes it all finally click into place. So let's start with a classic head scratcher. You've got half of something and a third of something. Why can't you just smash them together, add the tops, add the bottoms, and get 2/5? It feels like it should work, but it doesn't. It's just plain wrong. The real question is why? Well, you've heard that old saying, right? You can't add apples and oranges. And that is exactly what's happening here. A half and a third are just fundamentally different things. They're different size slices. Before you can combine them, you gotta get them speaking the same language. And just look at this, it shows the problem perfectly. That piece that's 1/2 is obviously a different size than the piece that's 1/3. They're totally different units. So before we can even think about adding them, we have to find a way to re-slice them into pieces that are the same size. And here's a fun little fact for you. The word fraction itself, it comes from the Latin word fractio, which literally means to break into pieces. How perfect is that? We really are just dealing with the broken bits of a whole number. So, how do we solve this whole apples and oranges dilemma? We have to find that common language. We need a way to make our different size pieces comparable. And in the world of fractions, we have a name for that. It's called finding a common denominator. Now, the secret weapon for this whole operation is a concept called equivalent fractions. These are fractions that look completely different, but they actually represent the exact same amount of stuff. Think about it. 1/2 of a pizza is the exact same amount of pizza as 2/4, or 3/6. It's just been sliced up differently. So how do we actually make these equivalent fractions when we need them? Well, it's a beautifully simple trick. You multiply your fraction by the number 1. But, and here's the really clever part, you disguise the number 1 as a fraction, like 2/2, or 3/3, or in this case, 4/4. And boom, here's what that looks like in action. We take our 1/2, we multiply it by 4/4, and we get 4/8. The numbers look totally different. And yeah, we have more slices now, but because all we did was multiply by 1, the actual value, the amount of pie you get to eat, is exactly the same. Now, we could use any old common denominator, but to be efficient, to keep our numbers small and easy to manage, we want to use the least common denominator, or LCD. It's just the smallest possible number that both of our original denominators can divide into perfectly. It's our best, most efficient common language. Okay, let's bring this all back to our original problem. For 1/2 and 1/3, the smallest number that both 2 and 3 can divide into is 6. So we're going to convert both of our fractions into sixths. 1/2 becomes 3/6, and 1/3 becomes 2/6. And just like that, they're speaking the same language. And now that the pieces are the same size, we can finally add them. 3/6 plus 2/6 gives us 5/6. Easy, problem solved. Or is it? Because sometimes, solving one problem just leads you straight into another one. Yes, sometimes even when our answer is technically correct, it can be a little clunky. It's not in its most elegant, easy to understand form, and that's where simplifying comes in, or reducing a fraction to its lowest terms. For example, imagine you do a bunch of math, and your final answer is 120/90. I mean, sure, that's a number, but what does it even mean? It's so big and complicated, it's hard to get your head around it. We can, and we absolutely should, simplify that. So, what's our goal? We want to get to what's called an irreducible fraction. That's just a fancy way of saying it's in its simplest form. A fraction where the top number and the bottom number have no factors in common, except for good old number 1. To do this smart way, we need a different tool for our toolkit, the greatest common divisor, or GCD. This is simply the biggest number that divides perfectly into both our top number and our bottom number. So for 120 and 90, that number is 30. Now check this out. The process is a perfect mirror image of what we did before. Instead of multiplying to build a fraction up, we're dividing to break it down. You just find that GCD, and then you divide both the top and the bottom by it. It's clean, it's direct, and it gets us right where we need to go. And look at that result. That clunky, hard-to-picture fraction, 120/90, simplifies down beautifully to a much more manageable and intuitive 4/3. It's the exact same value, just expressed in its cleanest, most elegant form. Okay, so we've looked at two different things, right?
We've seen building fractions up so we can add them, and we've seen breaking them down to simplify them. They seem like complete opposites, don't they? Well, get ready for the big reveal, because they're not.
In fact, they are two sides of the exact same coin. Think about it. When we build fractions up, we multiply the top and the bottom by the same number. When we simplify them down, we divide the top and the bottom by the same number. It's the same action, treating the top and bottom equally, just going in different directions. And this brings us to it. The one rule that governs everything. The engine that makes this whole thing work. As long as you multiply or divide the top and the bottom of a fraction by the exact same non-zero number, the fraction's actual value doesn't change one bit. This is it, the fundamental property of fractions. It isn't two separate rules for two separate problems. It's one simple, powerful idea that lets us reshape and rescale fractions to do whatever we need them to do. It's pretty elegant, right? So next time you see a fraction, just remember this one big idea. It's all about changing the form without changing the value. And, this concept goes way beyond math. Whether it's converting currencies to compare prices or finding a common goal to get a team on the same page, this idea of finding a common unit is a powerful tool for understanding the world. Where else do you see it at play? Thanks for watching.